Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, we will solve a question on binomial theorem, which is a part of the syllabus of AS level mathematics and additional mathematics. So question is in front of you and you have to find out the values of A and N as given in the question here, right? So the binomial expansion you have to do for 1 plus ax power n, and its expansion is given to you here, and you can see very clearly there is no a and n. It means when you will expand it, you will have a and n, and then definitely we'll compare both of them, this expansion and your expansion. So let's start comparing it, expanding it very quickly. Formula I have written here for you, which will be given to you in MF 19 as well. So let's start. Okay, so I'm taking 1 plus ax power n. Okay, so in the above expansion, which is the formula, I'm going to expand, and in place of x I will write what? Ax. So everywhere where I have x, I will write what? Ax. And how many terms I will open it up to? 3 terms. 1, this is term 1, term 2, term 3, and the rest I will not open because I have to compare it. So it will be 1 plus nc1, okay, 1 plus nc1 a times x power 1 plus nc2 ax power 2. That's all, right? After this, I will apply the formula here. It will be 1 plus, achha, by the way, I hope you remember that NCR is written as n factorial divided by n minus r factorial into r factorial. So exactly this formula I'm going to apply here at NC1 and at NC2. Okay, so let's do it. Let me move it a bit to the left side. Okay, so this NC1 will become now n factorial divided by n minus 1 factorial into 1 factorial, just with the help of this formula, nothing else, times ax, because power 1 will keep it ax. Then I will write n factorial divided by n minus 2 factorial into 2 factorial, and what will I get here? A square and x square. After that, I have to simplify it. Now you know, I'm helping you here to recall also, right? You know that n factorial, if we expand it, we can write n times n minus 1 times n minus 2 and so on. Or at the same time, if you have to stop at any point, you can stop it just like this. Or if I have to go up till n minus 2, then I can also stop here, depends. So in the first case, what will I do? I will stop in the numerator at n minus 1. Do you know the reason? Why would I do that? Absolutely right, because n minus 1 is in the denominator. And 1 factorial is 1, so I'm not writing. You know, this 1 factorial is 1, so there's no point writing here. So now this I can cancel it. Agreed? So that's why I have stopped at n minus 1. The second one I will stop where? Tell me. Absolutely right. At n minus 2 I will stop. And the only reason is I have n minus 2 in the denominator. And 2 factorial is what? 2. Okay. Now, after that, what did I get? 1 plus nax, because you know this will multiply this n with this. Now this will cancel out and I will have n minus 1 over 2 a square x square. Now this is the expansion of what? Of this 1 plus ax power n. But what was the expansion given to us in the question? Here it is. Just a second. So what I will do, now I will compare the two. So let me take this part there. I hope it can easily be moved there so that it is in front of you. Okay, so I will compare it with this now. Okay, so I will write here comparing the coefficients. So comparing the coefficient of Can you tell me which coefficients I'll compare? First one is 1 and 1. So fine. Then I will compare the coefficient of x power 1. So such that this side I have NA, and in the given one it is what? Minus 12. So from here, if I take A as a subject, it will be minus 12 upon n. You can also make n a subject. That is your choice. Why did I make A a subject? Because when I will solve simultaneously, in this term, A is present only here. N is present in two places. So I would have to substitute in two places. So I'm trying to avoid that. Okay. Anyway, so now I'm comparing the coefficient of x square. So in this term, it is n minus 1 a square upon 2, and this side it is 63. So what this will become? n minus 1 a square. I can multiply 63 by 2. So this is my equation 1 and equation 2. Now I will solve them simultaneously. And I will substitute this value of a here, right? So let's do it here. So it is n minus 1, and the value of a is what? Minus 12 upon n square equals to 126, right? So let's start it now. N, just a minute. I don't want to expand it. You know why I don't want to expand it right now? Any idea? Yes, those who got it, absolutely right. I have n in the denominator, so I would like to cancel it. It will make my calculation simple. So this n can cancel with this. And where this minus sign has gone? Because whenever we have even power, negative become positive, because minus times minus is plus. Absolutely right. So now I have n minus 1 times 144 and 126n. I will multiply this by this. So 144n minus 144 equals to 126n. Now you have to find out the value of n. Simple algebra. I hope it is not an issue at all. What is 144 minus 126? Mentally or calculator, your choice. 18n is equals to 144. So n is equals to 144 divided by 18. What is the answer? 8. So the value of n is 8. Now I have to find out the value of a. So what was a here? You can substitute either in equation 1 or in equation 2. I am taking equation 1, where a is equals to minus 12 upon n. So a will become what? Minus 12 upon 8. You can simplify it. 4 2s are 8, 4 3s are 12. So what is the value of a? Minus 3 upon 2. Absolutely right. So I'll solve another question of more or less same type, in which you have to expand and do the comparison. So thank you very much for watching. Please press like and subscribe button and share it with your friends. Take care. Allah Hafiz.